Hello learners, welcome to this course. So MMPO 006 Marketing Research. I am Dr. Venkataya Chittipaka in the School of Management Studies, Indira Gandhi National Open University. You have already been introduced to the need, scope and applications of marketing research. Further, you have also been introduced to research design and also the sampling design, data collection methods, scales of measurement and development of the questionnaires, etc. Now in this session, I am going to introduce the concept of the data preparation, part 2, which includes the missing value data treatment, introduction to software, because as you know that yesterday we have discussed all about the data editing and data coding and the data classification, right, as a part of the data preparation. Going forward in the same data preparation, the extension to the editing, coding, classification is the all about knowing the missing value data treatment and the kind of softwares that are going to be useful for the treatment of the data, right. So here missing value data, because it happens always that in majority of the researches what happens, once we collect the data from the field, it is necessary to clean up the data actually, right. So while doing the cleaning up of the data, there is a possibility of encountering certain kind of the missing values in the data set. So in that case, you as a researcher, how you are going to uh, handle this kind of missing values in the uh, data set collected from the field work, right. So today I am going to throw some insights to make you understand the missing value data treatment, right. So here coming to this case of missing value data treatment, it's a crucial step in the data cleaning process of the data science, if you remember, right, because data is the lifeline of the research, right. So as we go forward conducting the kind of the analysis, so that the data plays a vital role here. So missing value treatment is a crucial step in the data cleaning process of the data science, and this missing value data treatment, it refers to the techniques and the methods used to handle the missing values in a data set. And in any data set, missing values occur when there is no data available, right, for certain observations or the variables. So these missing values can hinder the accuracy and reliability of the data analysis and the predictive models, because the missing values are going to actually make a lot of the disturbances in the entire data set, and ultimately the it's going to have its influence on the outcome of the data actually, because as a scholar, as a researcher, we are going to collect the data with utmost care, but in spite of that, some of the respondents may not have filled the data sheets properly, right, have not answered properly in spite of certain kind of counseling schedules and all the kind of the measures that we are going to adopt, but still we are going to experience this kind of the missing values, because missing values are going to occur when there is no data available for the certain observations or the variables of the study, and these missing values can hinder the accuracy and reliability of data analysis and the predictive models. And just about everyone doing analysis has some missing data, especially survey researchers or the marketing researchers, database analysts and the researchers and the social scientists are always going to work on this kind of the data sets, right. So missing data are the questions without answers or variables without observations. This is how we can write, we can say in a single sentence. So missing data are questions without answers or variables without observations. So even a small percentage of missing data can cause serious problems with your analysis, leading you to draw wrong conclusions. So this is how the missing values are going to produce the misleading in kind of outputs, which in which in turn going to result all the wrong conclusions, right? This is how we can try to understand the missing values, the role of missing values in the data set, right? Now going forward to understand, because how do we address these missing values, what kind of or the solution, what kind of treatment as a researcher you are going to follow, right? There are various certain methodologies that we adopt to clean the data set, right? And then accordingly you are going to check the consistency of the entire data that we are going to that you have collected from the field, right? So coming to the point of the data cleaning, here the data cleaning always talks about the thorough and extensive checks for consistency and treatment of the missing responses, because in the data cleaning process we always concern about the consistency and the treatment of the missing responses, and which includes the consistency checks and the treatment of the missing responses as well, right? So although preliminary consistency checks have been made during editing, the checks at this stage, at the stage of the data cleaning, are more thorough and extensive because they are made by the computer. Because when we are talking about the editing and coding and the classification part, so due to this nowadays majority of the scholars or the researchers are using the technology as a interface to completely work on the entire data set, right? So here the preliminary data the checks, the consistency checks have been made during the editing process, as we have seen, and the checks at this stage are more thorough and extensive because they are made by the computer, right? So this is how we try to understand the data cleaning process, because nowadays majority of the scholars are using the computers. It may be the applications of MS Excel or SPSS or SAS or Minitab, whatever the available software packages. Using that, most of the people are cleaning the data, right? So going forward here to understand, the next one is the consistency checks. As a scholar, how do you check the consistency of the data set, right? So as a part of the data cleaning process, how do we understand this consistency checks? Consistency check is a part of the data cleaning process, which identifies the data that are out of range or logical inconsistent or have the extreme values. Data with values not defined by the coding scheme are inadmissible here, because yesterday we have seen in the previous session we have understood all about the coding and editing and the classification part, right? So when normally we do the coding to the data, right? So accordingly we convert the qualitative information into the quantitative information, because we collect the data from the field by assigning certain kind of codes, and the same codes are going to be entered in the computer, so that the numbers, we are converting the qualitative information into the quantitative information with the help of this coding, right? So the data with values not defined by the coding scheme or admissible, inadmissible, we can say, right? So and identify data that are out of range and logically inconsistent or have extreme values. Out of range data values are inadmissible and must be corrected when we are now checking the consistency checks on the collected data points. So for example, respondents have been asked to express their degree of agreement with a series of lifestyle statements on a scale of 1 to 5. Assuming that 9 has been designated for missing values, data values of 0, 6, 7 and 8 are out of range. And here the computer packages like SPSS, SAS, Excel, Minitab can be programmed to identify out of range values for each variable and print out the respondent's code, variable name, a record number, column number, and out of range values. This is how we try to check the consistency. We try to always identify the missing values using the various computer packages, right? So this makes it easy to check each variable systematically for out of range values. The correct responses can be determined by going back to the edited coded questionnaires, because while we were talking about the editing and the coding and the classification, because the editors are going to take utmost care to while doing the editing process by marking with the kind of the various colors of the pen, or with various the marking systems, that is going to be easily identified either it is being edited or not edited, right? So this is how we the correct responses can be determined by going back to the edited and coded questionnaires. This is how we try to always check the consistency. And because in the missing value data treatment, data cleaning and then consistency checks plays a vital role to understand the data in a better manner, right? And going forward here to understand further all about this missing values. So the responses can be logically inconsistent in various ways. So for example, a respondent may indicate that she charges long distance calls to a calling card although she does not have one, right? Or a respondent reports both unfamiliarity with and frequent usage of the same product. This is how we can see the inconsistency in various ways. And the necessary information like the respondent code, variable name, record number, column number, and inconsistent values can be printed to locate these responses and take the corrective action as accordingly. Otherwise it is going to create a lot of the queues in the entire data sets, and then it leads to produce a misleading information or misleading output or the results, right? So finally, extreme values should be closely examined here when we are doing the consistency checks. Not all the extreme values result from errors, but they point to the problems with the data actually, right? So for example, an extremely low evaluation of a brand may be the result of the respondent indiscriminately circling once, like on a scale of 1 to 7 rate, on all attributes of this brand like this, right? So this is how we try to check the consistency, and accordingly we go forward, right? And now the treatment of missing responses. Now so far we have understood all about the missing responses. Now let us try to understand how do we treat this missing responses. How as a scholar you are going to find out a solution to this missing responses. How do we treat it, right? So here missing responses, as we have been talking about, it represents the values of a variable that are unknown, either respondents provided, either because the respondents provided ambiguous answers or their answers were not properly recorded, right? So the former cause is also known as the item non-response, that occurs because the respondent refuses or unable to answer specific questions or items because of the content, form, or the effort required. So this is how we can understand the missing responses. And the treatment of missing responses poses problems, particularly if the proportion of missing responses is more than 10%. See here, the underlying point here, the treatment of missing responses poses the problems, particularly if the proportion of missing response is more than 10%. We have to ensure the kind of the non-responses in the entire data set. So there are certain kind of the options available for treatment of the missing responses. So there are four options are available for a scholar for the treatment of this missing responses. So the first one is the substituting a neutral value, and the second option available is the substitute an imputed response, and the third one is the case wise deletions, and the fourth one is the pair wise deletions. These are the options available for the treatment of the missing responses in the case of the missing values in the data set. Now let us discuss one by one what are all these four options, and let us try to understand all about these four options available so that we can ensure to try to avoid all these missing responses, because it's a laborious process. Because when we start working on the data sheets, it actually puts a lot of pressure on the scholars to work on, to clean up and then put it in a more acceptable format, so that the software can read your data and then accordingly it is going to generate the output, right? So as a scholar we have to take utmost the care and concern about the data being collected, right? So here the treatment, how do we treat these missing responses, right? The first treatment is the substituting a neutral value, right? So here a neutral value, typically the mean response to the variable, which is substituted for the missing responses. Thus, the mean of the variable remains unchanged, and the other statistics such as correlation are not affected much, right? So, although this approach has some merit, the logic of substituting a mean value, let's say 4, for respondents who, if they had answered, might have used either high ratings 6 or 7 or low ratings 1 or 2, is questionable, right? This is how we try to always substitute a neutral value and then try to avoid all the kind of consequences which are going to be part of the missing values, right? So here the second treatment is the substitute an imputed response. Substituting imputed response is all about the respondent's pattern of responses to the questions is used to impute or calculate the suitable responses to the missing questions, because the responses are going to be carefully after examination of the careful examination of the responses, the other questions is used to impute or calculate a suitable response to the missing questions, and the researcher attempts to infer from the available data responses the individuals would have given if they had answered the questions as well, right? So this can be done statistically by determining the relationship of the variable in question to other variables based on the available data. For example, product usage could be related to household size for respondents who have provided data on both variables, and the missing product usage response for a respondent could be calculated given that the respondent's household size, right? Because the respondent's household size is a part of the response, right? So accordingly you are going to calculate the respondent's household size, and then however this approach requires considerable effort and can introduce a serious bias, and sophisticated statistical procedures and have been developed to calculate imputed values for the missing value responses, right? So here going forward, as a part of this treatment of the missing responses, a project was undertaken to assess the willingness of households to implement the recommendations of an energy audit. It's like assume that it is a dependent variable given the financial implications. So the independent variables consists of 5 financial factors that were manipulated at known levels, and their values were always known by virtue of the design adopted. However, several values of the dependent variable were missing, and these missing values were replaced with the imputed values. The imputed values were statistically calculated given the corresponding values of the independent variables, right? So the treatment of missing responses in this manner greatly decreased the simplicity and validity of the subsequent analysis. This is how we can try to understand the options we have so far seen. The first option is substituting a neutral value. The second option is substituting an imputed response, right? And the third response is that for the treatment of missing values is a case-wise deletion. A case-wise deletion, it is a method of for handling missing responses in which the cases or the respondents with any missing responses are discarded from the analysis in the case of the case-wise deletions, because here you are going to discard from the analysis all the missing responses, right? What happens in this case-wise deletion? Cases or respondents with any missing responses are discarded from the analysis, number one, and because many respondents may have some missing responses, and this approach could result in a small sample, and here throwing away large amounts of data is undesirable because it is costly and time consuming to collect the data when we are following this case-wise deletion method in the method of the treatment of the missing responses, right? So furthermore, respondents with missing responses could differ from respondents with complete responses in a systematic ways. So if so, case-wise deletion could seriously bias the results, right? So this is how the case-wise deletion we can try to understand and its implications. And the fourth option, the last option, what we can say is the pairwise deletion. So as you know that pairwise deletion is a method of handling the missing values in which all the cases or respondents with any missing values are not automatically discarded. Rather, for each calculation, only the cases or the respondents with the complete responses are considered, right? So this is how we try to understand the pairwise deletion of the missing responses. So typically in this pairwise deletion, instead of discarding all the cases with any missing values, the researcher uses only the cases or the respondents with complete responses for variables involved in each calculation. As a result, different calculations in an analysis may be based on the different sample sizes. This procedure may be appropriate when the sample size is large, and when there are few missing responses and the variables are not highly related. So this process can produce results that are unappealing or even infeasible as well. And the different procedures for the treatment of missing responses may yield different results, particularly when the responses are not missing at random and the variables are related. Hence, missing responses should be kept to a minimum, and the researchers should carefully consider the implications of various procedures before selecting a particular method for the treatment of non-response. And finally, it is a good practice to use more than one method of treating missing responses and examine the impact of the different methods on the results, so that you can understand the importance of all the missing values. Right. Now, moving forward, after understanding this data cleaning process and then managing these missing values. Now we are going forward to understand the tabulation, right? So here tabulation, here the mass of the data collected has to be arranged in some kind of concise and the logical order, right? So the tabulation summarizes the raw data and displays the data in the form of some statistical tables that we are going to use in the due course of time. And tabulation is an orderly arrangement of the data in the rows and columns so that it gives the clear picture to all the researchers. And the objective of this tabulation is that, so here it's all about conservance, because this tabulation conserves space, minimizes explanation and descriptive the statements. And the second one is the same tabulation is going to facilitate the process of comparison and summarization, because it is all about it's a data sheet which gives the full statistics all about to understand the entire the database, and facilitates the detection of errors and omissions as well. And the fourth objective is to establish the basis of various statistical calculations in this tabulation part, right? And there are basic principles of tabulation to be followed by the scholar or editor, right, whenever they are going to work on it. So the first principle is the tables should be clear, concise and adequately titled. And the second principle is every table should be distinctly numbered for easy reference. Otherwise, again there is a it's a part of the poor editing process, I can say. And without having the numbering and then coding or the source information, etc., right? So the column headings and the row headings that all should be clear, and also the brief, right? And units of measurement should be specified at appropriate places, and explanatory footnotes concerning the table should be placed at appropriate places. And the sixth point is it's all about sources of information. The data should be clearly indicated. These are the basic principles of the tabulation, right? And then the columns and the rows should be clearly separated with the dark lines. And then democratization of should also be made between the data of one class and that of another one, it is right. So here comparable data should be put aside by side, and the figures and the percentages should be approximated before tabulation. And democratization will also, because the figures and percentage should be approximated before tabulation. And the alignment of the figures, symbols, etc., should be properly aligned and adequately spaced to enhance the readability of the same. And the another principle here is that the demarcation of should also be made between the data of one class and that of the another class, actually, because let's say for example in a typical university there are several in institutions, or the several the divisions are there. All the divisions need to be work together, so that the classification of the data is going to be easy. Actually, the alignment of the figures, symbols, etc., should be properly aligned and adequately spaced to enhance the readability of the same, and the abbreviation should be avoided. These are the basic principles of the tabulation, right? So with this I am concluding the session for today. Thank you.